So what is the limitations of the KNN? Why we in generally have not used the KNN as our as a computation? So because if you just see our text review data set, suppose here using the text review. In test review data sets, if you just see, if you just collect a data for a, suppose for a news websites, we have collected a news data for a year. Suppose for a year we have collected, and we are just to conclude the summarize of this year. What is about a year? This year is actually a negative year or a positive year. Just we are work doing these jobs for using machine learning. Example, you can see approximately how much data actually we have collected. So for suppose for time, suppose let's take it's approximately 364. We have collected approximately the number of data is 364, and the dimensions for each data is approximately, let's take 100k. Because in real case this thing is not happens. From this number there are a large number of data sets, billion of data sets, but let's take for here I'm taking some small data. So suppose let's take this is actual our data for our training purpose, detrain data. Okay, now if you just see, just in previous lecture we have seen that our time complexity for KNN for evolution phase and space complexity in evolution phase is order of ND for both phase. We have seen this thing in the previous lectures. Just see this thing. Now we are calculated these things, means order of ND. ND means now what? ND, if you just see ND, I think K 1000 into 1000. So it's approximately 364 36 million, approximately 36 million number of data sets. It will be approximately this, means for storing this amount of data sets approximately we will need it 36 GB of space to store this data. For to store this data we approximately, not accurately, approximately we have required 36 of GB of 36 GB of RAM, or only for evolutions, only one algorithm. So for a company to build a 30 cb, to apply a 30 cb RAM for one calculation of one algorithms, we need approximately 64 GB of RAM system. 64 GB of RAM system. Approximately we need this system to calculate it 1 GB, to calculate it one model, simple one model, 36 GB of RAM. Because of this minimum we require 36 GB of system. Okay, so this is a huge expensive for a company. A simple for simple one query point we have to invest, invest is so huge money, because this is a one limitations of K. Now this is one thing. Now let's take another thing, is time complexity. Let's see how actually in space complexity we see this in how large system actually we have needed. Now let's see the time complexity. So actually what amount? So I think it's approximates equals to 36 billion data, approximate equals to 36. So for time complexity, so for time complexity we calculated, we have to calculate it as well as time complexity is order, also order of ND. So we have to calculate it 36 billion computation. We have to calculate it 36 billion computation. Okay, so if you just see this thing for internet company or for a trading or finance company, this is a natural thing. for an internet company, and for a finance or trading simple for a trading company. So if you just see the data of a share market trading, so there is a huge amount of data they are have. For every second, for every milliseconds, the data is changing. So actually their have data size is so large, but their required time is so small. Actually, for a review data sets, for if you just see this type of company, so for a data required for a review, suppose let's take for a review data, actually they need its output, they needs it output only for one simple millisecond. It's required its output only on milliseconds. If you if you just see this trading company, just if you just build a machines for one query point, if you just have to wait some minutes or some seconds, also some seconds. So this is a huge time for a trading company or for a internet company. If you just go a Google and search a word, and what's about the meaning of this word, what is actual internal meaning, actually it is positive or negative, actually for just typing it, and if you just wait for a second, 10 second or 50 seconds, so you can easily leave this site. Okay, you can don't go just for one query point. Actually we require 1 millisecond requirement for output, and also we have to in backend we have to work with for so huge large data. So how it is possible? So because of this thing, because of this, to make a low latency model, to build a low latency model, to be simple, to build a low latency model or model, we simply avoid this thing. Okay, or low latency in because of this reason, only because of this thing, we cannot use KNN. Or you don't be confused, low latency means fast model, fast, very fast. Fast means very fast model if you require. And we have in backend we have to calculate it so huge large data. That's we see in an internet company or trading company. But this thing is not matter in medicine company. In trading company or internet company, if there have some error, it will not matter, it's okay. But if you just see some medical company, medicine company, if you just see in medicine company, so their latency is not matter so much. If you wait some seconds, then it is okay. If we wait some second, then it is okay, then it is okay, medicine company. But here require what? Here it's require accuracy. For accuracy, here data we have required very accurate data, so it is our output. In medicine company we have seen that here latency is not matter so much here, but here accuracy matters so much. Here we require accuracy very large. We need this thing, accuracy is so large, but not latency matter. So it's depend on our situation to situations. So this is main drawbacks of simple k-nearest neighbor. But actually we are using because of this simplicity. We have simple, although we are also simples using its knn, it's we have seen its time as well as its space complexity is so large. Order of AND, but its advantage is that its simplicity, its intuitiveness, intuitivity, and it's elegant. Because of these things, we use KNN, nothing else, because we can easily interpret it, we can easily intuit it, because it's simple. We have finding the distance and calculated the majority of the distance. Because of simplicity, we can use it. You can use the KNN. And also in the previous after in the end of the series of this lecture, we also see one structure, KD tree. KD tree we have seen. Okay, by simply using the KNN trick, also we are building the KD tree. We also see after past of this of the end of this series of lecture, we will see this thing. Okay, I think the how the limited this KNN is, why we are not using in real world for a production purpose, for a for actually in real world, why actually we have not used this thing, because of this time and space complexity, but nothing else. But the main advantage is its simplicity, intuitiveness, and its elegance.